welcome back to High on History. I'm Jordan, and this is Liz. Um, so, uh, shoot, I don't even remember. It was your episode last.
Yeah.
Yeah. Uh,
We talked about Blombus Cave, and we talked about Wonderwork Cave, and we talked about some early signs of artistic and symbolic thinking. We talked about Homo erectus controlling fire, which had been, previously thought to be purely the province of Homo sapiens, but now we know probably not.
Okay.
Yeah, and this journey through prehistoric Africa has just been
phenomenal.
Oh,
Just
so
amazing.
so informative, and we've got such a chewy episode for you guys tonight.
Episode tonight.
It's so chewy that we're actually probably gonna
Cut it in
half.
Yeah.
And do the second half
Yeah.
on your next week. But we're gonna get as far as we reasonably can. Dinner is cooking and we are so hungry. So we're gonna do the best we can.
Yeah, right. So welcome back to Reigns of Africa. This is part 2.
Part 3? Yes.
Is this part 3?
I think so.
I thought
Because I'm doing the Ruins Rewriting History.
Yeah, I think this is part 3. I think this is part 2. I think I went and checked, and I think this is part 2.
Oh, okay.
This is Aqualithic North Africa, 50,000 years ago to 20,000 years ago. And since I'm cutting my episode in half, this first half of the episode, I'm specifically kind of focusing on genetics, as well as the climate effects and how some of our haplogroups possibly mutated.
Now, you're going to have to explain to me what a haplogroup is. Like, I've been hearing these terms all week: haplogroup, phenotype. I get how the genetic history here is super, super important, but as soon as they would start talking about that, my head went all like,
So that's where my passion lies. I always wanted to be a fucking pathologist. Sorry, language. Oops, my bad. I always wanted to be a pathologist. I love anatomy. I love physiology.
You really should speak up a little bit.
Oh,
I don't know why you're speaking all shy. You're so loud.
I've been so loud all day on the phone. I'm tired.
Fair enough.
So, anyways, I went down a genetics path, and I guess why not start at the real quick biology lesson, since I did mention going down the genetic line. So
yeah,
what a haplogroup is, it's actually technically half of your DNA.
Which half?
It can be either or, depending on what type of haplogroup it is.
So wait, it can be either through your mom or your dad?
Yes. That's why it's called a haplogroup. Hap meaning half. Your phenotype is your whole genotype, or your whole DNA. Your phenotype is you. And then your haplogroup can either be from your mitochondrial DNA, which is from your mother, maternal haplogroup, which I will be mentioning maternal haplogroups here in a little while.
Or your paternal haplogroup
which
through your
comes
dad.
your Y chromosomes.
So Y chromosome, okay.
Yeah, and being female, your haplogroup would be part of your chromosome that does come from your father when that egg is fertilized. Even though you don't have the Y chromosome.
So then if they were genetic, I just want to make sure I'm clear here. So if they were to genetically test my skeleton, and they found out my haplogroup, that would be through my dad? Because I'm a girl?
No. So mitochondrial DNA is linked through your mother, and that is where that is one of the main linkers. But a haplogroup is your mother's chromosomes and your father's chromosomes coming together to make your phenotype.
Okay.
Does that make sense? So you get your mommy's DNA, your daddy's DNA. You get half from mommy, half from daddy.
Yeah, so how do they tell, then aren't you always two haplogroups?
And that's where the science actually gets away from me. I did not go to college to get biology.
Okay,
and it's
all right.
been decades since I
That's going to be the into that rabbit hole for now then.
Yeah.
All right. I'll let you continue with this. I'm just curious.
Comes from one haplogroup will be your mitochondrial DNA that can come from your mother, and the other is your Y chromosome haplotype. And these are your genetic markers that help the scientists, help the researchers actually bring us down or classify us to one specific common ancestor or inherited genetic markers. So now some phenotypes and some haplogroups can be linked to one ancestor, one common ancestor. Others show up, and because we haven't found the bodies due to climate, due to archaeology, due to whatever reasons why we haven't found the one common ancestor, there's usually a group that specifically come from a region that show up dominant of that culture. And
so it's traits that are, among other things, it's traits that are also forming in specific areas over time as people get to know each other.
Exactly.
Okay.
And this is actually kind of important to remember for any and all of my episodes that I'm going to be talking about for Paleolithic era. Okay. And that goes for Europe, that goes for Asia, goes for every continent. Haplogroups is something I'm going to come back to quite a bit.
In case y'all haven't noticed, Jordan and I have very different styles for tackling this material. So this should be lots of fun, because we'll be going through all these areas, like the same way we're doing Africa now, all the way through time.
So now, tonight, we're going to focus on some top-level haplogroups, which these are the oldest lines.
So like the San tribe. Oh wait, but you're in North Africa.
Except I'm in North Africa, and we're talking about the Otarians, who they don't actually have a tribe name until we get down to Mali and Nigeria, and once we start getting to a little more 20,000. And I'm speaking specifically 50,000.
Where's the story starting today?
Yeah, okay, so we actually begin the real story in the Ice Age 50,000 years ago. The rainforest is starting to shrink and fragment. The rain is barely falling, so it's going through a drought right now. It's giving way to savanna. The dunes are making their first appearance in the world, in Africa. So, not in the world, in Africa. And our Atarians, who I guess I should actually describe who the Atarians are. And the Atarians are a culture of people who lived across the entire Sahara for pretty much 150,000 years.
Wow, that is...
Well, from 150,000 years ago to about 20,000 years ago. Now,
is this a phenotype group? Why are they the...
So they are called the Atarians because of a cave there was a cave in Belatir, Algeria, Bir El Ater. Sorry, I have a hard time combining those words together.
I've seen you stumble over English. Don't worry too much.
Oh, English is my worst language, and I speak it. Okay, so the Atarians are the great-grandchildren of the Acheulean people, which they were the tear-shaped tool people.
Okay. We talked about them a little bit, I think,
one of my last episodes.
So the Acheuleans kind of morph into the Aterians.
Yes, and these are just basically...
I have another question. So are the Aterians archaic or modern humans?
They are technically Homo sapien.
Okay, so modern Homo sapiens.
They are Homo sapien.
Nice.
So this is 50,000 years ago.
Okay,
150,000 years ago.
150,000 years.
And Homo sapiens show up 300-something thousand years ago, 400,000 years ago. So we are looking at modern Homo sapien Atarians. They're just the younger generation of the Acheuleans, they're the younger generation of the early hominids. And when I say younger, I mean closer to us.
Just to help me piece together, you said that they inhabited all of the Sahara.
All of North Africa.
Or all of North Africa.
Yeah.
Okay, so then are we talking about the Acheulean people moving back and forth and intermixing and interbreeding, and that's why we have these Aterians, because we've got North Africa and West Africa and Central Sahara all kind of mixing it up, right?
And that's why I get all into the scientific genetics stuff.
Okay, I just wanted to make the...
So,
I just wanted to make sure I knew what was up.
yeah. So we get, they span from the grasslands of Cameroon all the way up to Morocco. Once you reach North Africa, once you reach your half of North Africa in East Africa, you'll even run into the Aterian people.
Right, because they're going to be in Libya, right?
They're in Libya, they're in Egypt, they're all the way in Ethiopia.
Nice.
They are.
Okay, so they're...
Oh yeah, they are the entire, I honestly do believe, because of migration, because of climate, because of all sorts of stuff, I actually do believe that the Aterians might be the grandparents of the Khoisan nations that you were talking about. Because of the Ibo-Maurasians, who are their grandchildren, the Aterians' grandchildren, who come down and they're in Cameroon, that you'll eventually find them in Sri Lanka Cave, which is close to your environment.
Well,
you'll find
the
them down
were
in
down
Congo,
in South Africa 100,000 years ago, too.
but
yeah.
you find them migrating down into, so I think they all intermingled.
And that's the Bantu people there also, right?
The Bantu don't show up until about 4,000 years ago. So I won't even get to talk about the Bantu people in my region.
That's going to be my region.
Depending on how we switch to continents, that might be your region. Yeah. But let's see. I kind of lost my place because we're not actually going entirely through this verbatim, which is fine. We weren't supposed to go through this verbatim. This is literally me putting my notes together. We get, let's see, we talked about where they're from. I'm trying to just make sure I'm on the right page. Where we started our story, what a haplogroup is, and now, okay. So we get the haplogroup U6 appearing about 40,000 years ago. And that's a distinctive marker that you'll see in the Tolfolat Cave. And I'm going to skip talking about basal Africans because they are different than the Aterians because they never actually mingled with the Monsturian people.
And who were the Monsturian people?
The Monsturian people, which I might be saying it wrong because I don't speak French.
Can I look?
Yes, let me point you to the right word. There it is. Mousterian, and that's named after the French guy that found it, and yada yada.
Mousterians.
Yeah. And they're the Neanderthal and the Hobbit people.
The Hobbit people?
The Hobbit people are the Homo florensis.
Homo florensis?
Yes, Homo florensis, which is from Southeast Asia, or Southwest Asia. I don't entirely... Yeah, Southwest. Yeah, Southwest Asia.
Okay, can I just read this? This is helpful.
Sure.
Basal Africans were cut off from their sisters of the north, or didn't leave Africa and mingle, but would eventually give life to the Iber-Eurasian people in about 30,000 years, with the maternal haplogroups called U6. Haplogroups U6 appear 35,000 to 40,000 years ago, when a new migration of Homo florensis, or hobbits, hooked up again with the next generation of Mousterians from the Levant through Europe and down into modern-day Spain and Portugal. Nowadays, U6 is found in all non-basal Africans and is called the Back to Africa gene. This gene will make an appearance again at Tolfolat Cave.
Cool, thank you for reading that.
Yeah, that was helpful. Thank you.
Yeah. Okay, so then basal Africans also, which is really kind of unique, didn't start changing on a genetic level. Like, their phenotypes didn't start changing with the U6 mutation that showed up 20,000 years ago until about 3,000 years ago.
Okay, so it took a long time for that to start mingling. Okay.
Yeah. And so the Ibermerasian people are the ones who mingled with the grandchildren of the Atarians and the Mousterian people. Now, we're focusing just on the Atarians, but all of these names are going to come back. We're going to
continue to be talking about these. We're going to try to paint the picture as well as we can.
Yeah. In a couple episodes, I am going to be talking about the Ibermerasians, and once I get into West Africa, I'm going to talk about the Basal Africans. Okay. Because there is a difference. And I mean, like I said in here, please remember this jumbled family tree because it does actually matter. But ultimately, the Arturians are the main focus right now. And to understand Topherot Cave, U6 is kind of the main focal point.
And U6 is the Arturians.
Is a specific genome that phenotype haplogroup that shows up
in the Arturians.
In the Arturian population.
And they were found in Topherot Cave.
And this haplogroup shows up in Topherot Cave with the haplogroups H, U, JT, and V.
Okay, so U6, H, U,
JT, and V.
JT, and V.
Yeah.
Who are they?
They're really flippin' cool because they are from all over the world. But to understand this part of the story of the rabbit hole, in Topherot Cave, there were 34 human remains found.
Oh.
31 were tested, but for some reason I can only find the results of 21 of them.
Okay.
Yeah.
Okay. I mean, sometimes tests take a really long time, and sometimes the results come back with meh.
And that's kind of what I'm thinking. 10 were inconclusive. But out of the 34 tested, 21 came back with results.
And were they all from the same time period?
All of them tested between the ages of 20,000 years and 11,000 years.
I mean, that's a lot of 1,000 years.
It is, but this is kind of unique because these remains show a distinct cluster of people that are not mixed with any other culture. They don't show up anywhere else. They only live in this region for that time period and then completely die out. They show a bottlenecking population decline at this cave that is specific to this location.
Oh.
Yeah, so during this time, 20,000 years ago when these people were living.
So they were a distinct people
that just died out completely.
And did I get you right? They were transcontinental? They came from other places in the world?
Yes. Well,
that's so cool.
Did.
Or the phenotype did.
Mm-hmm. Mm-hmm. Their DNA came from other parts of the world.
That's cool. So and again, so back into Africa.
Yeah. Now, making sure I'm on the right page. Now, on top of just showing that there was a population decline, the remains are also possibly some of the earliest indicative. I hate that word. Indicative.
Thank
you.
Or indicative.
Indicative. There we go. Please finish that sentence for me.
Sure. Where's this site? At this site of Griot de Pigeon, or Topherot Cave, the DNA found here is some of the oldest samples, suggesting close relations, a bottleneck population decline, and the remains are possibly indicative of the earliest evidence for the Caucasoid genomes developing in Africa before the genetic mutation of pale skin appears 3,000 to 5,000 years ago. This grave site was dated to 23,000 to 11,000 years ago and was referred to as, quote, the oldest cemetery in the world, end quote. In the cave, we find some of the earliest signs of ritualistic burial practices with those unique remains, and among the graves we discover some were anointed with medicinal oils, suggesting practical ritualistic use of herbs. I know at least one grave was found to be covered with large stones protecting the body within the shallow grave, Well, everybody was found to have been buried in a fetal position, and their hands were
Heads.
angled.
It should have been heads. Did that say hands?
Oh, no, you're right. It does say heads.
Okay. Okay, you can actually stop there because, like, think about what I have written there.
Yeah, no,
These people are showing signs of care for their bodies. They're anointing them. They're decorating them. Further on in that, I also have...
Let me finish that neat sentence, though.
Go for it.
Their heads were angled in a specific manner, suggesting care for their loved ones. I saw graphics, and we're going to try to get graphics up for you guys maybe as early as next week.
Yeah.
But I saw graphics of the positioning of those bodies, and it was so obvious that it was loving.
Yeah.
You know, just now I lay me down to sleep, sort of.
They really did care.
Yeah.
It was beautiful. No, so I can see where I'm at, please.
Yeah.
Okay. So yeah, and on top of that, let's see, I think you were just starting to say the specific care for the grave sites. And then also, like, being found, how all of these graves, the 34 graves, were found inside a rock shelter. You had read that one of them had stones that were on top of them, the anointment, all of that. By putting them in the rock shelter, that even shows that they're trying to protect the graves.
Yeah. Well,
It's almost like turning it into what are those grave buildings called?
A mausoleum?
Thank you. Yes.
I was thinking that also, if you wanted to have from a ritualistic perspective, I don't know if there were signs of ritual in this particular cave.
I mean, anointing them with medicinal oils.
No. I mean, other than the burials themselves. I don't know if there was any other sign of ritual. But if you, for example, believed that your ancestors guided you, you know, your people might have a specific place where the ancestors are buried, so that you would have a place you could go to pray. Believe that you know the spirits came and talked to you.
Right.
Just pointing that out, like,
well, I mean, you do bring up a really valid point about the whole potential ritual. This cave shows the signs of ritualistic burials 23,000 years ago.
right.
But the really unique thing is this cave does show other ritualistic practices after 20,000 years. My episode tonight specifically focused on the 30,000 years between 50 and 20,000 years ago.
Okay.
So I cut parts of my story out.
So we're gonna have to get some follow up here.
Yeah, so
okay.
there's a lot of follow up, there's a lot of rewinding. Hey, remember last episode? So if you didn't watch, starting with this episode, if you did not watch this episode, you're gonna miss everything.
Well, yeah.
Well, a lot of the beginning. So now that
we're trying to be on a semi-chronological.
Yeah, we're trying to be on
here.
a semi-chronological order. So also found with these remains were ostrich, got it right this time, I spelled it right, and whelk shells. And these shells were painted with
ochre.
Thank you. Ochre.
And didn't
Ochre.
you say they were also polished?
Oh, no, this is a different cave.
Oh, this is a different cave.
Spoiler.
Spoilers. Sorry.
All good. I can't wait to talk about Biz Mountain Cave. Oh, wow. It is 8 o'clock.
Sorry about that. That was not supposed to
No
happen.
worries. So no, this is not Biz Mountain Cave, but the shells were adorned.
They were adornments. They were jewelry.
Thank you. They were adornments. That's what I was trying to say. And then also the bodies were found painted with ochre on them.
Okay.
Showing, in my opinion, ritualistic practices.
Absolutely. One of the things that we discussed when we were talking about Blombus Cave last week is that we know that they were, they had a workshop set up there for making ochre paints. We don't actually know there if they were painting themselves or other things, but it does not take long to get from Blombus Cave to find people painting absolutely everything in ochre.
Oh,
everything in ochre.
I mean, since we're cutting this episode in half, in about 3 episodes of mine from now, maybe 4, I get in some really cool cave painting conversations.
Nice.
But so now here I'm gonna kind of start throwing around a little bit of hang on, I forgot. Also in these graves there were stone tools, bone tools, as well as certain animal remains. I think the term was ungulated they used, which means hooved.
Okay.
So there was like all sorts of really cool things also placed with these bodies in a caring manner. And now I read somewhere, I'm going to question it because of how old the bodies are, but they say there was even possible evidence of ritualistic tooth extraction.
Ritualistic tooth extraction? Doesn't that just dentistry?
I don't know what that means, but it's cringe. That's all I can say to that. And I question it because these sites are old. I mean, if you think about it, 20,000 years old, your teeth are fucking missing anyways, right?
I mean, how can you tell the difference between ritualistic and just deliberate tooth extraction?
I don't know. I know there's some really cool tribes that, like, carve their teeth into points. I know there's actual tribes of people who do that. So, I mean, like...
Okay, yeah, maybe.
Maybe.
I don't know. That just kind of sounds like dentistry to me.
Now, we're going to get a little more into phenotypes and genotypes because now I've talked about some of the really cool discoveries.
Wait.
Yep, now we're getting back into the genotypes and phenotypes because I had mentioned that we were going to talk about H, U, V, and JT and where they're all from now.
Okay.
Yeah. So now this is where you can stop me whenever you need to so I can help explain it a little bit better. I try to break it down super easy. I don't have a biology degree either. So, like, I don't really quite understand it all. But this is kind of how, like, to understand the migration and to understand the, like, where we come from, we really do have to understand these genotypes. Especially,
right, of course.
Especially for these people that I was just talking about at Tulsa Cave, because of where the first Caucasoid genomes come from in this area. At least is what it's suggesting.
Mm-hmm.
Now, I mean, I'm sure there's other Caucasoid genomes that are showing up in other parts of the world due to other environmental regions.
I actually found out something interesting about. So, I always had this like weird assumption that. I mean, I guess it's not so weird, but I figured humans were like wolves. And that, like, we got white because we came from the north where there was an ice age for, like, forever. And, you know, we needed to blend in with the snow. Because, you know, we don't necessarily want to stand out. And that turned out not to be the reason that folks got white at all, which, you know, I guess I could have just looked this up at some point. But one of the things that I was reading is that when people did initially go into Europe, when that first couple of groups got trapped up there, basically there just wasn't enough sun.
Right.
So the darker skin, which protected them from UV down in Africa, was also preventing them from getting like enough vitamins, like vitamin D and stuff from the sun, because it's just so little sun up there.
Right.
For so long in the year too, right? And so the skin started to get lighter over time in order to absorb more sunlight.
Yeah, I mean, that makes sense.
Or
that
more
absolutely
vitamins
does.
or
That
something.
absolutely makes sense. So, now, like I
I
said,
didn't confirm it. It was. I did not. I read that though.
No, you can stop me at any time to clarify. I am going to actually start reading from my paper, though, so I don't get jumbled.
Okay, sorry. Yeah.
Okay? Just because I want to make sure I'm not going to get jumbled. And then, so we're going to start with Homo habilis, or Homo erectus, leaving Africa 100,000 years ago. And this is when we first see the haplogroups N and M show up. And now, N and M is a predecessor to the haplogroups that I'm really focusing on in Tulsa Cave, But they migrate and mutate up along the Levant and Southwest Asia. N haplogroups migrate into the north, and I don't think that's that why.
In haplogroup, right?
Yes, N haplogroup goes north, which is how I remember it. I don't know if they did that intentionally. And that goes into Levant and eventually into Europe.
Wait, who goes in?
N.
No, N goes in
Haplogroup
north.
N, yep. And then M goes down and populates Asia.
Okay.
These groups become the Denisovians, the Neanderthals, and I forgot to mention the Hobbits. And this is referred to as these are referred to as the out of Africa genes, and this happened 100,000 years ago. So if you could imagine what the world is going to be like then.
We interrupt our regularly scheduled broadcast with a weather report from 90,000 years ago. Globally, we were in the Ice Age, mammoths, saber kitties, woolly rhinos, etc. And while the world is isolated.
Isolated. Get it?
Nice. Nice. Dad joke master right here. The Sahara was going through a massive drought where many parts of the south and east saw dune development. This climate change in Africa is called the Abasia pluvial pump. Even with a drier climate, most of the Sahara was still lush and green in the north and west regions. This is a vital bit of information to remember for our story because of the effect climate and geography really has on the evolution of all species. In this period of frozen tundra, we have the Denisovians, Neanderthals, and Hobbits thriving in their respective territories, still migrating, developing cultural practices, and even trade with the Arterians, who braved the harsh terrain out of Africa. The Younger Dryas begins around 50,000 years ago to roughly 20,000 years ago, and our ancestors are in an era called the African Human Period. As the rest of the world is starting to cool down for the Younger Dryas, our oasis for the last 30,000 years is starting to recede more and experience a harsher drought. We see dune development and savannas form for the first time. These two climactic events overlapped for nearly 3,000 years, yet the land is still very abundant and green. And now back to your regularly scheduled broadcast.
So, okay, we went over N and M, and that's when we get the divide of N and M and why they mutate.
Okay, so they're separated, and now they're starting to go their own separate ways.
Yep, and that's why we see them
and is that
mutate.
What's also happening to J, T, and H?
That is also what does eventually happen to them down the timeline.
Oh, okay.
They're actually much younger. N and M is 100,000 year ago mutation. They come from Homo habilis and Homo bergensis. When
Homo, not Homo.
It's been a long day. So, now that we're back to our regular broadcast, 30,000 years ago, the migration of haplogroups N and M, or about 70,000 years ago, we get another shift in the climate, and we get haplogroup R mutating. And the haplogroup R is called the peopling of Eurasia. Now, R is just a mutation from N and M coming back together.
Okay.
Now, so you get the Neanderthals of N.
Wait, where did they come back together?
Migration, just around 70,000 years ago, they come back together forming R.
Okay.
Yep. Now, R is the peopling of Eurasia. It gives birth to the 7 different distinct haplogroups. And these 3 haplogroup lines can all be found specifically on the maternal DNA line. So N, M, and R are specifically maternal linked.
And
they only show up through mitochondrial DNA.
And they show up all in Eurasia.
In Eurasia, Eurasia is both Europe and Asia, right?
The place where it's sort of...
all of that.
Yeah.
Is where they show up, and then and that 70,000 years ago when R shows up, they had migrated back together, and I guess they're the Monsturian people. I'm not quite sure. I haven't gotten into the numbers for what's going on up there in their timeline yet exactly. So now we get down to H, U, J, V, and JT. So JT comes down to a single root ancestor that can be found to one person.
Okay.
We've actually linked him to Italy. He's actually found in a necropolis in Umbria, Italy.
Interesting.
Yeah, like we actually have JT as our one single ancestor.
Interesting.
50,000 years ago. So he's actually one of the older mutations off of R.
Mm-hmm.
And he shows up in Tolfara Cave 20,000 years later. Now we get haplogroups U, which is numbered 1 through 9, which is just subgroups, subphenotypes that show up. We talked about 6. 6 shows up in 2 of them. U as a whole is the initial maternal founder of Europe. She is 40% of European DNA have U.
Okay.
She is the Neanderthal DNA. She is the mother of all of Europe, pretty much.
Okay.
Yeah. And with you showing up, she suggests to me that 46,000 years ago, our ancestors were absolutely migrating.
Yeah.
During the Ice
obvious.
Age, that was not a problem.
No.
We were not stuck in caves. We were vast traveling. I mean, we have JT and you showing up in Africa. That is a very long distance. You populates all of Europe, and Italy can be located, JT can be found specifically to an Italian region.
Okay. Yeah.
So, and all of those are on the maternal line still. So now, and I'm really emphasizing that they're on the maternal line, because H is even more unique. She shows up for the first time on both sets of haplogroups. She can be found on your mom's set or your dad's set.
Interesting.
Yeah, and she comes from Southeast Asia. So she comes in from, I'm going to assume she comes in from the Indonesian region,
Okay.
out that way, if I tracked her back far enough and memory recalls. She mutates 25,000 years ago, so now we're getting a little bit closer to where she's showing up, why she's showing up in Africa.
Mm-hmm.
And 25,000 years ago, we're the younger Dryas. It's cooling down, but it's also kind of being more abundant, so there is a lot more traveling going on now at this point. And then after we get H, we get our youngest. She's found commonly in the Basque people today. Like, she's the main populator of the Basque, and she's V.
Okay.
Yeah. She's found in the Iberian Peninsula. She's populated all of southwest of France for the most part. And she's actually the marking indicating gene. So whoever really has V, she's part of the mass migration out of Europe. So there was a migration apparently about 15,000 years ago back into Africa.
Right.
Which
right.
would make sense because once again,
It got
20,000
effing
years ago,
cold.
it was getting effing cold again.
Yeah. Yeah.
So and V is marked as the migration out of Europe gene. All of those find their way to Tolfara Cave and find their way to one specific family group,
That
one
is
tribe,
amazing.
one conglomeration of people.
Who had gone out into the world and then came back to this cave.
Over 100,000 years almost.
Wow.
To one spot.
That's
And
amazing.
they're said to be the ancestors, the grandparents of the Natufians, but there is no real evidence of that because they completely die out. There is no living haplogroup combination of these people in the world. And with that being said, that is going to be the end of our episode. I would love to go on and explore Bismuth Cave. I want to explore the rabbit hole of tools and all of the crazy fun stuff that I actually had written for this episode at Mesek Satafet Plateau. Because we really get talking about the industrial revolution of mankind starting 50,000 years ago to 1800s and got nothing on caveman. But I guess all of that is going to have to wait for the next episode. And if you like what we're doing, please hit that like button. Let us know that we're doing our job right. Share with your friends so they can rewrite history with us. By sharing, it helps us get out there. My goal is to reach 100 subscribers by the end of the year, so please hit that subscribe button. And if you have any questions, comments, hit them down below. And we'll give you a shout out in the next video. Liz? What are we looking forward to next week?
Well, we're going to be covering right around the same time period. But we're moving up into East Africa a little bit more. I'm really excited to start getting into some of the advancements. Among other things, I'm going to be talking about hafting tools and composite adhesives.
Cool.
So, yeah.
So I'm going to have to do a little bit of rewrite because I had a line here somewhere, and Liz is going to share this in next week's episode. So I guess next week Liz gets to bring on some differences that I might share following hers.
Yeah. So we're going to talk about some artifacts and yeah, we're just going to keep going, just kind of winding our way up the continent and talking about the amazing stuff that people start doing.
Yeah, so join me in 2 weeks for the development of culture.
Yeah.
The Aqualithic period.
Oh, yeah. This is when humans start getting real interesting.
Yeah.
So, like, subscribe, share, and as always, live long and prosper.
Bye.